name is Sri Ilaprolu. I lead our solution architecture practice at Amazon Web Services. And today what I thought I'd do is walk you through how customers can leverage AWS Cloud for disaster recovery purposes. Even though the talk is going to be about disaster recovery, backups, and such solutions, cloud in general, I'll actually get into some of that as we go through, could be used for pretty much anything that you're thinking about or you're currently doing in your own data centers. So, quick agenda. What is AWS? For those of you that may not be familiar with what AWS is and what we're doing in this space, some basics of disaster recovery, understanding some terminology so that as we move forward, we are on the same page. Why AWS for disaster recovery? Some of the services that are from AWS that could be leveraged in order to provide disaster recovery solutions, and then I'll get into common DR architectures that we see across our customer base. So what is AWS? At a very high 30,000 foot view, this is what AWS looks like. At the bottom of this is global infrastructure. I'll get into a little bit more details on the slides coming up here, but we have data centers across the globe, and that's where you'll be consuming services from, customers consume our services from. On top of that, we have networking services such as global DNS with 100% uptime SLAs, services such as direct connect that let you interconnect between networks, as well as the entire concept of software-defined network. On top of that, we have our core foundational services, compute, storage, and databases. In the compute family, you can think of it simply as virtual servers in the cloud. 32 plus instance types that we offer, various versions of Windows, various flavors of Linux, pretty much anything that you can run on an i86 platform will operate on that. In the storage family, we have support for 3 different types of storage. Block storage, which is what most customers are used to. Object storage, which is what I'll get into a little bit later. As well as archival storage called Glacier, where customers can put away data at a very, very inexpensive, using an inexpensive cost model, and then be able to restore it when needed. And then in databases, we have support for relational databases as well as non-relational. In the relational family, we have Oracle, SQL Server, MySQL, Postgres. In the non-relational, you can either bring your own version of non-relational, whether it's Mongo, Cassandra, or anything else, or we have our own flavor called DynamoDB, purpose-built for extreme scale. On top of that, application services, whether it's data warehousing, queuing, emails, messaging, notifications, analytics, as well as more recently, virtual desktops in the cloud, where you can actually launch 1 or 100 or 1,000 Windows 7 desktops in the cloud. And all of this on a pay-as-you-go model, which is what the key differentiator of cloud is. We also have an email service, fully managed, secure email service called Workmail, and another service called WorkDocs, which is a content collaboration, online collaboration, and content management system. On top of that, we have a number of services and features that we provide for deploying things into AWS as well as administering things once they're on AWS. So I mentioned we have infrastructure distributed across the globe. The way we think about this is we have certain geographies around the globe where we cluster our data centers. And those clusters of data centers is what we call a region. We have 11 such regions at the moment around the globe, and this is going to expand going into the future. 4 in US, 7 outside of US. Each one of these regions is then subdivided logically into what we call availability zones. So each region at least has 2. Most regions have more than 2. For example, the region out here on the US East Coast called US East 1 has 5 availability zones. One of the largest available regions of AWS as well as clusters of data centers anywhere in the world. In total, we have 29 availability zones across those 11 regions. In addition to that, we also have 50 edge locations. Edge locations are used for content delivery network where you want to deliver content or applications to your end users as low latency as possible. The key point here is customers decide where they want to launch their applications, where they want to store their data, and that's exactly where it is. For example, if you deploy and store data in US East region, that's where it goes. It does not move unless you move it out of a region. Especially important if you have continental US requirements or compliance reasons. And we have customers, for example, outside of US that have requirements that data cannot enter US, right? So exceptionally compliant. The way I mentioned, a region is then broken down logically into what we call availability zones. Simple way of thinking about it is an availability zone is a virtual data center. The reason I call it virtual is because if you look at behind the scenes, each AZ is made up of most likely more than one AZ data center. I mentioned US East 1, some of the AZs in that region have 5 or more data centers powering each AZ. So they're isolated from each other within a geography. They're isolated from each other. Fault isolation, different part of the power supply grid, different tier 1 ISPs, different network connectivity going in and out of the network, different fault lines, floodplains. The goal there is, the way they're architected is that complete fault isolation as much as possible, humanly possible. At the same time, they're also close enough, tens of miles generally, close enough that we can facilitate high-speed connectivity between them, private redundant high-speed fiber, with a latency of roughly 1 to 2 milliseconds between AZs. And I mentioned independent fault zones, multiple data centers. I think I already covered all that. So this is the latest Gartner Magic Quadrant for infrastructure as a service. This is actually a couple of days old. Gartner released the 2015 version on Tuesday. This is the latest one. And they have started doing this about 4 years ago, and ever since they started doing this, AWS has been in the leader quadrant. That's nice. So that's where we continue to be at. This year, some of the other statistics that Gartner has outlined. If you look at this, AWS at the moment has more than 10 times the aggregate compute capacity in use by customers if you take the rest of the 14 players in the entire Magic Quadrant combined. What that means is scale. The scale at which we're operating and supporting customers is extreme. Some of the more popular internet businesses, some of these names sound familiar to you guys probably. Netflix especially is one that gets very publicized, entirely dependent on AWS. Companies like Dropbox, Acquia, Foursquare, you're used to that, Clipboard, Airbnb and Pinterest, as well as a number of others. Not only startups in the enterprise space, the traditional old guard enterprises that have non-IT as their mission, we are serving customers in every imaginable vertical. Federal, DoD, intelligence, finance, state and local, healthcare, education, highly regulated industries as opposed to unregulated industries. Pretty much anything that you can think of, any industry vertical that you can think of, we have customers operating on top of it. The latest statistic on that is at the moment we're supporting over 1 billion active customers. And each one of those customers could be as big as, for example, Samsung, or as small as a single user trying to start up their own business. But overall, in 190 countries supporting over 1 million customers. Specifically in the public sector space, we have quite a bit of adoption as well. Over 1,500 government agencies across the globe using AWS, various degrees of adoption, some that are just launching small workloads on AWS, versus others that are adopting AWS in a massive scale. In addition to government, we have approximately 3,600 educational institutions, big name universities, K-12 districts all around the globe. Over 11,000 nonprofit organizations using AWS. Not only customers, if you look at the technology space in general, whether it's the consulting space, whether it's the technology ISVs, independent software vendors, makers that create actual solutions that you may be using on-premise, they're already supported on AWS. We divide that into 2 different categories. The first one is called consulting. This is where normally customers depend on these kinds of vendors to help them move or operate. Versus the other category, which is technology players, where companies like Microsoft, Oracle's, IBM's, and others that actually create solutions and software that perhaps you may be using in your own data centers. So some of the differentiators there are, as you saw through the Gartner chart, there are other players in the space as well. Things that differentiate AWS compared to others in the industry. Experience, we've been doing it the longest, since 2006, supporting, as I mentioned, a large number of customers across a wide variety of use cases. Innovation is another thing. We are constantly innovating on that platform. Last year alone, we released over 500 features, net new features added into the platform based on customer feedback. Right? Customers telling us that they would like, for example, a new feature to be added or a net new service to be added. That's what goes into the innovation curve. Robust platform, as I said, even though you may be thinking about cloud or AWS for a specific use case today, the platform is there with over 40 different services to be able to cater to future needs as you need to grow, as you would like to grow. Pricing is another interesting thing in that this is what generally draws folks to look at cloud. Cloud is cost-effective, cheaper than what I may be doing on-premise. Absolutely true. And the way you think about it is we have dropped for our prices 48 different times since we went live in 2006. I already touched on the global footprint. Touched on the global footprint already, and the ecosystem we have thousands of partners, as I mentioned earlier, ISVs, SIs, consulting, systems integrators, consulting partners that can come in and help. A large ecosystem of developer community that's building tools towards AWS, on AWS. And one unique thing about we have an offering called Marketplace. If you're used to Amazon.com, you log in, you search for something that you're interested in, you find it, one push, you're done, right? You get the product delivered to you, whatever delivery mode you selected. What we're doing with Marketplace is very similar for software. So let's say you want to try SAP or Drupal, right? Generally what it takes is you get the software, you find the hardware to deploy it on, deploy, configure it, hopefully you got it right, or you may have to bring in consultants to help you with that. And then you do a proof of concept. Maybe good, maybe not good, depending whatever way it is. And then you actually decide to go long term with it if it's successful. What Marketplace allows you to do is one click, find the software, once again. Once you find it, one click, it actually launches the infrastructure, deploys the software, everything ready to go in your account within minutes. All of this on a pay-as-you-go model, which means no licensing commitments, no upfront purchases, no commitments whatsoever. Try a product for, let's say, 4 hours, you find it useful, perhaps that's when you come into it. Otherwise, if you don't find it useful, stop and stop it. So we have 33 different categories in which we have over 2,000 different applications, and that's a very fast growing. It was launched about 2 years ago, and it's one of those products or offerings that is catching on. Certifications and accreditations. In general, security is #1 priority at AWS. As you can imagine, without security and without compliance in place, customers will not be as at ease to move into cloud. So we've worked on that right from get-go. We have achieved and we maintain certifications across the board in various segments, depending on what our customers' needs are. So for example, we have certifications that are more internationally oriented, ISO 27001 that talks to international standards. Quadrant, for those that are familiar with federal mandate for cloud adoption. Quadrant, we have monitored. ITAR for export compliance, any data that's subject to export compliance regulations. FIPS 140-2 for encryption standards. In the UK, we have a certification for a government of UK to be able to adopt AWS. We have to go through certifications for that. SOC, which most of you are familiar with, if you're operating data centers, SOC is Service Organization Controls that talk to how things happen in our data centers. FISMA is getting more and more outdated based on FedRAMP. Motion Picture Association of America, we have obviously customers on the West Coast that deal with a lot of content, digital content, and privacy and protection of that content, so we have certifications related to that. PCI DSS Level 1, which is financial and payment industry, extremely stringent certification to get. We have level 1 certification on that. Software is more public. Quality standards on how things are done within AWS, high quality and standards associated with that. For defense industry, we have DISA certification. Australia, there is number 1. MPCCS is Singapore. IRAP is once again Australia. Actually, this too is Austria, European standards. And then HIPAA finally is for healthcare. What I'm getting at is pretty much what our customers, whichever segment, market segment they're in, depending on their needs, we can go back to our platform team and have that come up. It's a single platform. We're not doing a HIPAA healthcare cloud or a federal cloud or none of that. It's a single set of control, single set of platform that gets to meet the highest bar there is to. So let's talk a little bit about disaster recovery, some of the basics. 2 terms that I want to introduce: recovery time objective and recovery point objective. If you're familiar with DR, these terms will sound familiar as well. What the goal here is defining how, in case of a disaster, how quickly do you want to recover from the disaster and how much data are you willing to use? What that means is if recovery time and recovery point objectives are low, you're thinking more real-time replication, real-time, always-on kind of systems, right? Versus if they're high, you're willing to be down for a longer period of time, maybe perhaps the system doesn't need to be up always, or you're willing to suffer some data loss. So those 2 terms are important. The reason for that is it's not a single thing that meets all of your requirements, meaning you may have different kinds of applications, different solutions, different use cases in your data centers, in your business, day-to-day business. Not everything is always on, or not everything is always only backup and restore. So depending on what kind of application, what policies you have to comply with, you have to decide where on the spectrum do you want to operate. So as I said, we have some systems that are more backup, offsite, and then if something happens to the primary location, we restore data, we pull the data down, back to the primary, hopefully the primary is back up, pull the data down and restore from that data back up, right? Versus if you go more fully on 24/7, have to be up, mission critical, can't go down kind of system, that's when you get into true DR situation where it cannot go down. So why AWS specifically for disaster recovery? This is what we see our customers, when we talk to customers about how are you currently doing disaster recovery. Those that are actually doing disaster recovery in the true sense, talk to us in this way. This is the primary site, so they have a lot of things that sit in the primary site, right? The servers, the networking gear, and all of that. For systems, because they may have systems that need to be up 24/7, what they end up doing most often is set up a second site, clone everything from an infrastructure point of view, from an operations point of view, just in case if the primary goes down, the secondary will pick up. The downside with this is you're duplicating your costs for the most part of the time. Unless the primary goes down, the secondary is never really used, which means you're unnecessarily wasting resources. What happens with AWS, and this is the key, you only pay for what you use, right? So what happens there is, unless you are in a disaster recovery mode, you're paying very minimal for the DR capability that exists on AWS. And the reason why I highlighted this is most likely you're taking data from your on-prem systems and backing it up periodically or constantly into AWS, which means you are paying for storage-related costs. The rest of the stack, compute, networking gear, and others, you're not, because you're not necessarily using them. When you need it, when the primary site goes down, it's literally flip a switch and things start back up. And I'll actually walk you through different scenarios on how customers are adopting. And 4 different drivers when customers look at why do I need to think about a different way of doing disaster recovery. Obvious one is reducing costs. If I can reduce costs for my DR solution, wouldn't it be nice? I may have situations where, especially in the metropolitan areas where I may not have I may need to reduce my on-prem infrastructure footprint. I may be in a process of consolidating my site, so when I'm doing that, I'm reducing my number of data centers that I may be operating. So why set up a second data center or perhaps multiples of those for purely disaster recovery needs? And then I may have aging technology where servers are coming up for refresh. So I have a decision point where either I commit and pay upfront and bring net new servers, or I think about doing disaster recovery in a different way. So some of the services that from AWS that customers use in order to do disaster recovery, storage is obviously key. That's where you put your data from on-premise, you're backing up constantly, you're either doing on a periodic basis or constantly replicating. So a number of offerings in that space: simple storage service, which is an object store; Glacier is an archival store. Import-export mechanism is to get massive amounts of data in and out of data centers, our data centers. And then storage gateway, which sits on-premise, it's a virtual appliance, or could be multiples of those, to constantly move data off from on-prem into AWS, as well as it can work reverse as well. Networking services, we have three that are relevant here. Direct Connect, which is you may be doing constant replication, which means you cannot really rely, you need a dedicated line between your network and, let's say, AWS. That's what Direct Connect allows you to do. Private fiber connect between endpoints. Virtual private cloud is once you come into AWS, rather than just getting into a massive cloud, wouldn't it be nice if you logically carve out a section of that and you define everything that happens inside of it? Who gets in, what kind of data gets out, all of that in your control. That's what VPC allows you to do. That's the software-defined network as technology. And then Route 53, which is DNS, we'll get into that, to do automatic failover, so that zero downtime kind of failover. And then some of the foundation services, this kind of gets into more of the optional state, in that if you have compute nodes, most likely you do, that's when you use our Elastic Compute Cloud, EC2. If you have databases as part of your solutions that you need to think about, then there's a service called Relational Database Service, RDS. And then finally, a block storage device. It's not in the object, it's not in the storage platform, because these devices actually get mounted to compute nodes. Okay, so some characteristics about our storage services. Simple Storage Service, or S3, was the first service that launched in 2006. Is now currently supporting trillions of objects on behalf of customers. Comes with 11 nines of durability. Pretty much translates to, if you put something in S3, the chances of you losing that object because of fault of S3 is astronomically low. 1 in 10 million kind of low. Extremely durable. And the way it happens is when you upload something to S3, by the time we acknowledge, which is a second or two, that we have received it, that object is already replicated within the region into multiple physical locations. Therefore, even if we lose two facilities at the same time due to a disaster, we can still recover your data. But it never leaves the region. It gets replicated within the region for compliance reasons, but never outside of the region. Unlimited storage, and only pay for what you use, right? So this is one of the huge benefits that we see for customers is, rather than procuring hardware and storage devices that I may not be using for now, maybe I'm thinking 5 years down the road, I'm purchasing a vast amount of storage that I'm paying right now. This is pay as you go. As you consume, you pay for it. And just to give you an idea, in the US East region, we bill at 3 cents per gigabyte per month. So extremely low in terms of cost as well. Glacier is another storage model. So S3 is natively online, always on, anytime, anywhere you can do it, you have access to it. You obviously have controls as to who can get to it, who doesn't, and all of that. Glacier, on the other hand, is not online, it's archival storage. It takes roughly 3 to 5 hours to retrieve data off of Glacier and put back on S3 so you can actually access it. And 3 to 5 hours, while it's not natively online, is exceptionally good compared to traditional tape kind of backup systems. And this one, similar durability, similar characteristics, all of that, but this one actually bills at 1 cent per gigabyte per month. So from a cost point of view, if you have workloads or data sets that you need to retain for legal reasons or regulation reasons, that would be ideal. And we're seeing a lot of adoption of that. And then finally, Elastic Block Store. This is a device that you attach to the disk or to the compute node. It actually needs to be updated now. This is 16 terabytes now. So we can attach a disk or multiple disks of 16 terabytes each to the compute node, and you can use that as a local base. Already touched on this, 3 different ways. Direct connect is the direct fiber connectivity between the networks. If you don't want to go that route, you can do what's called VPN connectivity between networks. In this case, you're going over the public internet, however, using IPsec tunnels, so security built in. And then no matter which way you come into AWS, you'll most likely end up with what's called a virtual private cloud, where you define the network structure, subnets, the ACLs, the route tables, pretty much everything. You're normally doing in your data center, you're defining it in VPC. 4 different architectures that we commonly see across our customers. And this, once again, touches into, do I have to have the system 24/7, always on, cannot go down? Or is it more of a, I'm okay as long as I can restore and recover from data loss? So backup and restore is more of that, I'm okay, I'm going to put the data offsite, and then if something happens, I can pull that data down and restore from it. We'll walk through pilot light, warm standby, where you have things to fail over as quickly as possible, and then a true always on, never go down kind of scenario. So let's look at the backup and recovery situation. Very easy, simple way to think about it is I have data that's sitting in my, let's say my NAS or SAN or local systems. Taking that data either nightly or depending on however frequently you want to do, back it up, put it in the cloud into most likely S3. And if something happens to the data, whether it's a disaster or something happened and the drive died, I can restore from it and recover from it. So easy to use, cost effective in the sense that I have offsite backup. But it's not going to get you to the true DR mode, right? In the sense that there is downtime. If something happens to the primary, I have to pull it down, restore from it, and then get back up on. So when I say there is downtime, it could be as low as few minutes to as high as few hours, depending on how much data you're pulling down. So walk through it. So take backups of your systems, move it to S3, and then if you have backups that don't need to live on S3, for example, you can think about archiving them off to Glacier if you need to. Otherwise, you can get rid of them and get stuff in for them as well. So this is how it would look like in action, right? So this is your infrastructure or your own data center. 3 different modes in which you can move, think about moving that data. One, I talked about direct connect. Second one, which is over internet connectivity using VPN tunnels. Or a third one, which is what most customers use when they're getting started, where I may have 50 terabytes worth of data on-premise that I need to think about getting it over as a one-time thing. And then from there on, I'm going to do nightly or daily or however frequently, once a week kind of backups. So this is a mass move. These are more ongoing daily moves. Once data gets into S3, now you have the option, if something happens to a primary, let's say, okay, so once data is in S3, you have 2 different options actually. One, the first one is to pull the data back to on-premise if something happens. If you lose a disk or you lost data, you can pull it down. Or the other is if let's say something happens to the entire data center, I'm down. Right? I need to get to my data. I can't wait till my data center is back online. In that case, optionally you can attach or launch virtual servers, compute nodes in AWS, pull data from S3 and get back online really quick. And this is what we see some customers doing, which is rather than waiting for that data to come down, why not quickly spin up a few virtual servers, attach to my data, start reading that data, and then if necessary down the road, I may be pulling it back on-premise and recovering from it. So quick way where I can pull the data off of S3, launch into an EC2 instance. We have what's called Amazon machine images. You can create your own images. These are virtual images of your servers that you would spin up from. Second is pilot light. This is where you're now not thinking I'm going to be down for long. Right? I need to recover as quickly as possible. I can't be down for hours. So in this scenario, typical example here is, let's say you have a site. Typically what we see is websites, right? Public-facing websites cannot go down no matter what happens. In that case, and I have a 3-tier architecture, web server, app server, and database server. Most logically. You may or may not have all 3, depending on the situation. But in the complex scenario where you have all 3, what we're seeing is data gets replicated constantly, or as frequently as you need to. These two tiers, web and app tiers, get replicated once, right? So once you get the data over into compute nodes, and then shut those nodes down. So you're not paying for those compute servers. Shut them down so that when you need to, you can quickly spin up a matter of minutes and everything is operational. On the database though, because data probably is changing constantly as your users are using the application and things are moving transactional, you're replicating constantly. And when a DR scenario arises, that's when you flip over at the DNS level quickly, get these two servers launched, or actually these two servers do not necessarily mean one server per tier. This could be a farm of servers, similarly horizontally scaled. Those two launched, the database perhaps was running on a smaller server because all it's really doing previously is receiving change bits, right? But now that it needs to take over the full production load, you can scale it vertically if necessary. And all of this could be automated for you as well. And a third model, which is where it builds on the previous one, this is where you cannot wait too long for dump. You can't wait for too long where the sites are offline. In this case, you're leveraging our DNS service as well. This is optional. You don't have to do it through Route 53. If you have your own DNS provider, most customers continue to use that. But at the same time, we also see a lot of customers flipping over here because there's a lot of value that comes with it as well. It can automatically detect failures on either side. It can automatically fail over when things go bad, or it can do additional features like latency-based routing and such. So in this scenario, very similar. You have replicated your application and web tiers. Your servers in this scenario are actually running. They're not scaled up to full production load. They are probably running on a very small capacity. Database is receiving changes constantly. And so you notice that none of the traffic is going over to the AWS side. Everything from a user perspective is still operating within your own data centers. When things go bad, this is when using Route 53 or using your own DNS service, you do a DNS level redirect. And if necessary, you scale up these nodes horizontally or vertically, depending on your application, and you're fully ready to take production load. This kind of setup is cost effective in that you're not running a full stack production ready DR site, but at the same time, when needed, you can really get there in a matter of minutes. Last one, which is probably the most complicated in the sense that it's also zero downtime type situation. Very similar. Now you have both sides, both on your on-prem data center as well as AWS in an active configuration, where both sides are ready to receive traffic. And in fact, if you have it in this configuration, why not send half the traffic in either way? Or you may decide that I'm always going to send traffic here, and if something happens, Route 53 will automatically fail over, and these nodes get automatically scaled up, so that there is zero downtime. So when things go around, it can scale up as well. I know we're coming up on time, so a number of resources that are available. There's a white paper that goes through very detailed as to how customers are adopting AWS and some of the best practices in adopting AWS for disaster recovery. But with that, any questions? Anything I can help address?
Would you flip back to that last slide, please?
Yeah.
Thank you.
And all of these slides will be available as well.
Okay. Thank you.
Yeah.
How would you handle replicating an on-premise virtual desktop solution, pretty much, or infrastructure? You guys actually, have you known anyone to actually do that?
So we do not at the moment replicate on-premise desktop solutions into, so I guess what are you using for on-prem desktop VDI?
View.
Citrix?
No, sir, VMware.
Yeah, okay. So you have a couple of options, whether it's for desktops or VMware-based vSphere servers, right? There are tools that we provide as well as partners provide that will let you do constant replication into EC2, which is our compute equivalent. where you're receiving all the changes that are happening on premise into this node, and then when things you need to spin up, you can quickly spin up from that. In terms of purely desktops, we have a product called Workspaces that I mentioned earlier about virtual desktops in the cloud, where customers are now no longer actually running on-prem VDI solutions anymore. Because infrastructure costs, operational costs, when I need to, may or may not be appropriate in this situation, but let's say I have a situation where I have seasonal workers coming in, or I have educational institutions where I need to assign desktops to my students when the semester begins, right? 10,000 students come on board. Along with, previously institutions used to hand out library cards. Now, what we're seeing in a lot of institutions is they're actually handing out credentials for their virtual desktop. No longer laptops, no longer on-prem labs, none of that. It's going away in the sense that because where desktops are available, they're very cost effective, I still retain control and manage all of that from a policies and procedures and governance perspective. A lot of institutions and organizations are moving in that direction. So I guess back to your question about purely replicating desktops, I don't think we at the moment are looking into that. It's mostly the back-end infrastructure that gets it. Any other questions? Okay, cool. Thank you. I'm going to be in the exhibit along with Larry here, so if you guys have any questions, any thoughts, want to catch up. Thank you.